Now, this is something you'd want to do when you see a polynomial of 4 terms. It's not always possible to factor by grouping, but you'll quickly see if it's possible or not when you group them. So, step 1, group the first 2 terms and the last 2 terms together. Okay, so you can just do this, one of these. If you want to put parentheses around them, you can, but I usually just group them like that. You're going to factor out a GCF from each of them separately. So what is the GCF between x cubed and 2x squared?
X squared.
Good. What is the GCF amongst the second? No, 8. Remember, when you factor out a greatest common factor, you are dividing each term by that and putting it out front. So we'll have x squared. You're dividing each of these terms by x squared. So I'd be left with x plus 2. Now in the second one, I'm going to factor out an 8. Now because it was a positive 8, I am going to put a plus 8 here. 8x divided by 8 is x. 16 divided by 8 is plus 2. If you've done this correctly, and if you've successfully factored by grouping, bless you, you should get the exact same binomials, x plus 2 and x plus 2. If you get different ones, then you can't actually factor it by grouping. So essentially what you do from here is now amongst this whole thing, the greatest common factor between this term and this term is x plus 2. So basically you factor out an x plus 2. And then you're left with x squared and 8. So basically, some students just like to think of it as keeping only one of the x plus 2's and then bringing down what you're left with. This is your final answer. Well, I should say, check and see if you can factor further. This obviously cannot be factored further because it's already linear. This one is not a difference of squares, so it's not a perfect square. You can't factor that any further. But if you could, you would. All right, next one. Group the first 2 terms and the last 2 terms. And if you want, you can check by foiling. So you can always foil it, make sure you get back to the original. Notice that I didn't solve this. Isn't it interesting how I did not say x equals negative 2 here? Can you notice that? Why did I not do that? Because it says to factor. This is not solvable. You don't know what it equals. It's not an equation. Yesterday, a bunch of the questions said factor. Should have taken you 1 minute. You guys solved. Did all this work. You just had fun. Please read the directions. Okay, that's the end of my rant. GCF for the next one. What would the GCF between our first groupings be? 1. And between our second? 3. We factor that out. We're left with x minus 4. Again, when you factor out the 3, since it is a positive 3, make sure you put a plus. You can see that we've done it correctly because we get matching binomials. So you just take the 2 outside terms, the y and the plus 3, you put them together. And you only bring down one of the common binomials. Do not bring down both of them. If you wanted to check, you could foil that. All right, now we're going to run into a problem in number 3. In case you haven't noticed it already. We're going to have different symbols here. Which is going to prove to be a problem. Not a big problem, just a little problem. GCF for the first 2? X squared. GCF for the second 2? Ooh, very good. Who said that? Negative 9. Josh. You want to take out a negative. You'll see why in a second. If you just put 9, you'll realize that you'll need a negative 9. You'll fix your mistake before you keep going. When you take an x squared out of the first one, you're left with x minus 1. If you were to take out just a positive 9, Like, let's suppose Josh wasn't here to tell us. Let's suppose you took out a positive 9. If you're using pen, don't write this down. You would then be left with negative x plus 1. And you would quickly realize, like, those are not the same thing, right? So you didn't do it right. So when that happens, you just have to go back and change your symbols. So change that to a negative. And then negative divided by negative is a positive. Positive divided by a negative is a minus. And then you'll realize we have the same thing. Now, be careful that you don't circle your final answer before you're supposed to. This was another problem on our quiz yesterday. Can we factor further? Yes. X squared minus 9 is the difference of squares. So that's x plus 3 and x minus 3. Now, there were 1 or 2 people on their test yesterday that thought they could factor this. Yeah, it's a linear term already. Like, you can't factor a linear term. You can factor a quadratic, a cubic, a quartic. But this just stays x minus 1. Now, I don't remember if it was this class or first period, but you cannot factor a linear term further except taking a GCF out, like a 2 or something. But, like, that's it. What do we think? Pretty easy? Do you want to try the next field? Yeah. Okay, go for it. 4, 5, and 6. Cannot factor this any further. Yes, 4 is a perfect square, but 3 is not. This would have to be a perfect square also, like 16, 25, 36. It's not. All right, now this one, we should have gotten down to take out, let's see, what was our GCF for the first grouping? X to the 4th. How about for the second grouping? 16, but we would want a negative 16 so that we have the same signs. Good? Take our outside terms, bring them together. So we have x to the 4th minus 16 times x squared plus 2. You're not done. Oh,
yeah, you take the x to the 4th plus 16, you have to make it to x minus 2, x minus 2, x minus 2, x minus 2, and x minus 2. The factor of that, right? X minus 2 times. Oh, yeah.
Okay, you're close. You're close. Okay. Normally, if it was just x squared minus 16, right, we would do x plus 4x minus 4. Cool with that? So when you factor this down, you're going to factor it into x squared plus 4 and x squared minus 4. So that's what using a quadratic pattern is. Factoring it as if it was a squared, but do it with the 4th or the 6th or the 8th. So you're modeling it like you would with a quadratic, but with a quartic. We okay with this? Do you see how this works? Now, this one is not factorable. NF, not factorable. So just bring it down. Now, Augie just got a little too carried away with breaking everything down. Only one of these 3 is factorable further. Which one? The middle one. So this would go down to be x plus 2, x minus 2. The other 2 are not factorable because they're pluses, and one's not a perfect square. So those would just come down and be in your final answer. You just have to be careful. If you have any differences of squares or differences of 4ths or differences of 6ths or differences of 8ths, you can factor them just like they were a quadratic, but you just kind of divvy up the exponents in each one. All right, the back is nothing new. It's a review because some of us didn't do so well yesterday. These formulas aren't going away all of chapter 6, or next year, or the following year, for that matter. Pre-calc and calc. You need to know them. What would I do first for number 7? Take out a GCF.
4 to 8, right? Something like 34?
2. 2x, actually. Again, factoring only. Factoring, not solving, just factoring. Now, this is using the difference of cubes formula. Some people yesterday just did this. And they thought that was factoring. Or they forgot the formula, so they just figured they'd write something down. But like, people just left that as their answer on the test. Okay, that is just telling you what to plug in for the values in your formula. Okay. So, using this formula, we should have a minus b. So that would be 2x minus 3. It is not a negative 3. B is just 3. And then a lot of you still screwed this up, even though I like harped on it at the board so many times. A squared. When you square this, you have to square the 2 and the x. 4x squared. Plus AB. So we're going to add 2x times 3. 2x times 3 would be 6x. Plus b squared. Square the 3, that's plus 9.
So it would be 4x to the fourth?
No. That is our final answer. This one is never going to be factorable further, so don't waste your time. Remember, that's when we use our quadratic formula. If we were asked to solve it, we would use the quadratic formula. But we're not. Just factor. All right, we're going to skip over the next one. No, let's do it. Because it's a little different.
Take out a 3.
Take out a 3. This one has variables in the first and the last position, so that's why it's a little bit different. So this is really x cubed minus 2y cubed. If you're thinking about what a and b are. A is x, b is 2y. Basically take the cube root of the number that you're getting. And then again, we're using the difference of cubes formula, which is the minus plus plus formula. So this will be x minus 2y. A squared would be x squared. Plus AB. X times 2y is 2xy or 2yx. I usually do alphabetical order. Multiplying those together, plus 4y squared. Like, as we go through chapter 6, you're just going to get all these factoring problems, like, thrown together. Like, you're not going to know what to do when. You have to, like, just mix it up. Difference of cubes, sums of cubes, factor by grouping. Factor using a quadratic pattern. Okay, so this one, notice, it's a 6th power. I would not do factor by grouping because I can't group the first and the last 2 terms. I don't have 4 terms, I only have 3. So this is where you would use what is called your quadratic pattern. You already learned this, but we never did one with the 6th power. We only did 4th powers. Okay? If this were an x squared, right, we would just do x and x. That's why it's called a quadratic pattern. You're factoring it as if it were a quadratic, but you're just changing the exponents. So Jax, you're right. We're going to put x to the 3rd and x to the 3rd. 3 plus 3 will get me back to 6. Our last 2 terms have to multiply to negative 27, and they have to add to negative 26. What would those be? Negative 27 and plus 1. Now, if only that were the end of the problem.
X minus 3.
How do we factor something that is a cubic sum or difference with cubes? You have to use both formulas. So this is really x cubed minus 3 cubed. I promise you, it's not getting any easier. You have to learn the formulas. You have to have them ingrained in your brain. Otherwise, the rest of the year will be a struggle. x minus 3, x squared, plus 3x, plus 9. Like, you should just be able to do it. Substitute into the formula. Now the next one is the sum of cubes. The only thing that changes is the symbols, right? So this will be x plus 1. And then it's a squared minus ab minus 1x plus b squared. We are not solving any of these. You want to see if you can factor any of them further. Do we know numbers that multiply to 9 and add to 3? No. Do we know numbers that multiply to 1 and add to negative 1? No. That's our final answer. If the direction said to solve, first of all, it would have to have an equal sign, and then yes, you would be able to find answers. But we don't have to do that. We just want to factor. Try numbers 10 and, oh, we don't have time. Try number 10. Do guess and check.
Oh, yes, I love this. Totally matters.
Guess and check. So, you know, we could have 4x squared and 2x squared. We also could have 8x squared and 1x squared. Who knows? Who's to say? But we'll just pick that and start. I'm thinking that's what it is. Now, lucky for us, we only have a couple factors that can go in here, right? 3 and 1 or 1 and 3. So let's just stick one here, stick one there, and let's check. 12x squared minus 2x squared. Look at that, Mrs. Bennett, good guesser.
Oh,
So you have the answer key.
I didn't even look at it.
Do the like
This is the first time I'm teaching this class today. Period 1 is next. Now, are either of those factorable further? Careful.
Yes.
Which one?
4x squared.
This one. Homework is on Google Classroom. It is a mixed factoring by grouping. I think there's like 12 problems or 15 problems.
You're so funny.
All right, for our last example, we are going to choose factor by grouping because we see we have 4 terms. So we'll group the first 2 terms and the last 2 terms, take out our GCF, which would be x to the 6th. And if you notice, the symbols here are different, so we would take out a negative 1 from our second set. Bring down our minus 1. And we've done our job correctly because we do have the exact same binomials, here and here. So we'll take and we will factor this down into x to the 6th minus 1 and x to the 3rd minus 1. Now from here, we can actually factor significantly farther. First of all, the first one we can factor using a quadratic pattern. This would be x cubed minus 1 and x cubed plus 1. This would just be x cubed minus 1. Now if you notice, unfortunately, these are all sum and difference of cubes, which means we have to use these formulas 3 times. So the first one would factor into x minus 1, x squared, plus 1x, plus 1. The second one would factor into x plus 1 times x squared minus 1x plus 1. And then the last one would factor actually the same exact way as the first one because those are identical. So this would be x minus 1 times x squared plus x plus 1. And that's it. Homework is again on Google Classroom. If you go to Google Classroom, you will see that it is the first option, mixed factor by grouping. You are completing all of the problems here. Okay, even though the numbers got cut off here, you can just kind of put in whatever numbers you want, but I would assume probably 1, 3, 5, 7, 11, 13, and 21 maybe. But the answers are also provided. If you have time to check those out before class, those will be in the link provided below. But please make sure that you are completing the assignment and checking your answers, not copying.